So we're going to shift gears. We're not going to talk about what's going on in the national election, because we want to keep our minds off of it for now. And I'm happy to welcome you to the latest round of the CITRIS Research Exchange. My name is Ken Goldberg. I'm a professor in the College of Engineering, and have been fortunate to be very closely associated with CITRIS since its inception, and am director of the People and Robots Initiative. And we've been hosting a variety of exciting innovators and experts during the series online during COVID-19. And there will not be one of these events next week due to the Veterans holiday. But on the 18th of November, we're going to have a panel on COVID-19 and specifically response to the SEED awards. That SEED award outcomes will be announced, and there'll be a panel discussion with those researchers. And then there also want to note that the Women in Technology Initiative, thanks for that slide, is having competition to recognize women leaders. And so I just want to remind you that the nominations are due on Friday. So there's more information there if you search for Athena Awards. And also just quick guidelines before we get started, which is to post your questions in the Q&A box. And that should be in your Zoom browser. And then you just put a thumbs up if you like somebody else's question, et cetera. We'll read those as we get to the end, but just hold questions until the end, and we'll make time. We'll have about 10 minutes before 1 p.m. to take some questions with Oren. And now let me introduce this fine gentleman. He is as I mentioned, an old friend, and I've been super impressed by his career trajectory. After grad school at Carnegie Mellon, he went on to University of Washington and was a very extremely successful professor there. He was very early adopter, or I would say had saw the potential for the World Wide Web in the early 90s, and developed a number of different approaches to applying machine learning to problems on the internet in terms of search and clustering, natural language processing, analysis of reviews and prices, shopping. He was very quick to see the potential for this very large and growing data set to be analyzed with contemporary machine learning techniques, which he was developing. So that allowed him to go on to found a number of companies, and in a remarkable string of successes as a serial entrepreneur. These are listed on his Wikipedia page, and I would encourage you to go check it out, because literally every one of them was sold and acquired. So he has an incredible track record. And he was named the founding CEO of the Allen Institute for Artificial Intelligence, which is a major think tank based in Seattle for AI. And he has been super successful. It was funded by Paul Allen, the Microsoft billionaire, and has been running a number of programs there, including somewhat of a competitor to Google Scholar that he might touch on. But he has done his track record is really spectacular. And he also, I have to say, I've read a number of his writings and interviews online, and I find myself in violent agreement with Oren in so many things. He's a skeptic about AI in, I find, just the right ways, and so it's really a pleasure to interact with him. He's always got a fresh view on contemporary issues, and I'm really excited to hear what he's going to say today about the fight against COVID-19 and how natural language processing may be useful. So please join me in welcoming Oren Etzioni. All right, Oren, over to you.
Thanks, Ken. Really, we end up all as professors and such doing a lot of these types of talks, and it really appreciate getting a authentic introduction from an old friend. And we were reminiscing a few minutes back. I like all of you, right? I'm thinking about the election and fretting about it, but hopefully we can take our mind off it for a few minutes. Not the ideal time to give a talk, And suffice it to say that A, I'm wearing a blue shirt, and that's not an accident. And B, that Ken promised that if Trump concedes, he'll interrupt my talk to let us know. Right. Okay, so let me see if I've got the screen here. Okay, so here's the outline for my talk. So I guess I'm going to start with basic questions like, is AI good or evil? I'll talk a little bit about AI2, as we call ourselves, the Allen Institute for AI. I will delve in, as Ken said, talk quite a bit about Semantic Scholar, and then describe how we came up with this data set to help fight COVID. And I'll end with a few thoughts about AI and science. We are starting a few minutes late, but I think we'll have plenty of time for Q&A. Giving a long, drawn-out, detailed talk over Zoom is a recipe for disaster. So I'll keep things at a relatively high level, and happy to delve into more details in question period or offline. So let's start with the fact that AI evokes fear in the mind of a lot of people. And these aren't just quote, the unwashed masses. There's plenty of very smart people, very knowledgeable people, whether it's Bill Gates or even Stuart Russell on the Berkeley campus, who suggest that we should be afraid of AI. Nobody has been as dramatic about it as Elon Musk, who warns us with literally religious imagery, with AI, we're summoning the demon. And at the same time, you have equally smart and articulate folks like Rod Brook, who say, if you're worried about the Terminator, just keep the door closed. And of course, through the miracle, or not miracle, but through the technology of reinforcement learning, eventually this robot is going to learn to open the door, only to find out that there's a staircase behind it, and it has difficulty climbing the staircase. Once we solve that, there'll be the next challenge. I remember Ken giving a talk a while back about the challenges of gripping, right? We're making progress, but we're still far away from the conclusion. Andrew Ng of Stanford has said that working to prevent AI from turning evil is a little bit like disrupting the space program to prevent overpopulation on Mars. It ignores both the technical difficulties. Okay, we haven't gotten a single person on Mars, and we're already thinking about overpopulation. And secondly, ignores the potential benefits. You know, the way things are going, it sometimes feels like we need to get to Mars ASAP. So something to think about there. Earlier this year, I wrote an article in MIT Technology Review, a popular piece, that tries to put this conversation on a more empirical footing, right? So we have people bandying intuitions back and forth, philosophers like Nick Bostrom and others. And I asked the question, so how would you know if AI was really super intelligence, was really around the corner, really about to destroy civilization? And I suggested we define a notion of a tripwire, a canary in the coal mine. I call it canary in the coal mine of AI. And the idea is that if we cross this threshold, then we really ought to be thinking about it seriously. And before that, it's probably too early, in the same way that certainly I think we would all agree that when we invented fire, it was too early to worry about super intelligence. When we invented the computers in the 50s, it was just not a productive conversation. So what would be an example of a canary in the coal mine of AI? To explain that, I want to highlight the fact that machine learning today is still 99% human work. And machine learning is the set of technologies that Ken works on, that I work on, that are really responsible for the rise and improvement in AI performance, both over the last decades, and especially over the last 8 years or so, with a set of techniques called deep learning that was championed by Jeff Hinton and others who recently won the Turing Award, AI, Computer Sciences Nobel Prize. The point is that the inputs to a machine learning system, what's the concept that you're trying to learn? What's the data that you're going to run over? What's the labeling of the data? Is it positive or negative? What's the algorithm that's being used? And the many design decisions in the algorithm, the regularization, or using softmax, et cetera, et cetera. And then finally, and very importantly, the assessment of the output. Okay, so here's how we're doing with this machine learning process. And often we find that it's iterative. We have to go again. We have to refine the target concept. We have to change the data set, change the algorithm. All this is human work. It's done by highly trained individuals, often grad students in academia. And that means that the algorithm, the computer, the machine is really just doing the last mile. Once everything is in place, it's doing the statistical analysis to build a predictive model. And so I really think of machine learning as it's a misnomer. Okay, it's called machine learning. It's 99% human work. And the analogy I would give you is think about penguins. Saying the machines learn is like saying the baby penguins fish. What actually happens is the parent penguins go out, they dive into the water, they corral the fish. They're often hunting in teams. I've gotten to see this on a trip actually to the Galapagos. It was really amazing. They corral the fish. Finally, they catch some fish. They eat them, digest them, fly back to the nest, and as you see here, they share pre-digested morsels with the babies. So it's not the baby penguin that fishes. The baby penguin is just doing the last mile here. If, on the other hand, we had machine learning programs that could actually automatically formulate the machine learning problem. I'm not talking about what's sometimes called auto ML or something like that. I'm talking about deciding, okay, we really need to learn something, and here's how we would do that. Maybe the sub goal to say, okay, we really need to figure out how to forecast elections better, something Ken was alluding to earlier. Okay, what would we need to do that? How would we build the models? What would be required? That whole rich formulation that is done by people I was just alluding to, if we had an AI system that could do all that, as opposed to deal with the pre-chewed, pre-digested morsels of data, then we would have true machine learning, and then we would have an AI canary, and we'd have to think about it. Until then, AI is simply a tool or a set of tools, not a being. And again, the word tool is a metaphor, but really it's a form of programming. It's a form of software. Those of you who've used machine learning tools know that it's a kind of programming. And so very different from something that's about to destroy humanity. And then it's up to us to use this tool to benefit humanity. And I understand that benefiting humanity is part of the broader mission of CITRIS. So here we're very much aligned. So with all this in mind, the late Paul Allen founded the AI2 as a non-profit research institute in 2014. Our mission is to use AI for the common good. And our focus is on research. So we've become a leader in computer vision, natural language processing, and deep learning. We've had, now this is actually, I should update the slide. We've published more than 400 papers in top conferences in the field, won quite a few best paper awards. And most importantly, we're continuing to hire even in this tough climate. Our main office is in Seattle. We have a small office in Irvine, California, and another one in Israel. So that's the infomercial part of our program. We have a wide variety of projects ranging from the Mosaic project, which is led by Professor Yejin Choi, who shares her time between UW and AI2. And that project asks the question, how do we endow computers with common sense? How do we stop them from making really dumb or potentially really dangerous errors? It's an extremely difficult long-range problem. We have EMNLP, which both does cutting-edge NLP research, but also has created a widely used research library, probably the most popular library for people trying to apply deep learning to NLP research. It's open source, it's widely available. We have a number of other projects I don't have time to go into. We even have, as many universities do, an incubator where we launch startups. So Ken mentioned that I've done some of that in my dark past. I don't do that anymore, but we have extremely talented colleagues who do. And most recently, we had a startup that was sold to Apple for a reported $200 million. So that was in the field of AI on the edge. So we feel pretty good about what's happening on lots of fronts. The project I'm going to talk more about is Semantic Scholar, and that project is motivated by information overload. All of us, even if we're not academic, are inundated with tweets, Facebook posts, emails, Slack messages. It's overwhelming. In addition to that, if you're an academic, you know that there's something like 8 million new papers published every year. And the fact of the matter is that scientists can only read something like 200 of those a year, probably less as you get more senior and inundated with committees. So how do you find the right papers to read, right? Herb Simon is a major intellectual force at Carnegie Mellon. When Ken and I were there, talked about how attention is constant, right? Our ability to process information cognitively is actually constant. So we need better tools to do it if we're going to keep up with this kind of Moore's law of scientific publication. So with that in mind, we built Semantic Scholar with the idea that we're going to use AI to help people to cut through the clutter and home in on the key papers and the key results that they care about. And I'll, if the gods of the internet are good to me, I'll be able to show you a quick demo of Semantic Scholar in this talk. It's a free service available 24/7 at semanticscholar.org. So let me tell you a little bit about it. First of all, since CITRIS is interdisciplinary, I should mention it covers all academic disciplines. At this point, it has more than 190 million paper records in its database and has more than 8 million users per month, which is pretty exciting for a nonprofit that doesn't, we don't have marketing, as it were. So what is Semantic Scholar? Basically, we take scientific papers, which are PDF files, and we map them to a literature graph where the nodes are papers and authors, sometimes concepts, and the edges are relationships between them. We have a search engine similar to Google Scholar that I'll show you, allows you to search via keywords and metadata. And we also have paper detail pages. Think of a paper detail page as kind of a Wikipedia entry for a paper. It's really quite rich. Not only contains a link to the PDF so you can read it, but we automatically extract the figures, the tables, the references in the paper. If there's associated software, we'll find that. We look for slide decks associated with the paper, maybe videos, if that's how you want to consume content about the paper, blog posts, news articles that refer to it, et cetera, et cetera. It's really quite rich. And we also have author homepages, which I'll show you in a second, that have that information. One place where we've innovated is in thinking about citation metrics. So as you know, if you've been on a hiring committee or if you've been hired yourself, for better or worse, we live and die by this rather noisy metrics of how many times our papers have been cited. And we've realized that actually that's both really noisy, but also it's just too much. Imagine a paper from 2005 that's been cited 1,000 times, and the papers that cite it from 2007, 2010, those have been cited 1,000 times, and you keep going on and on recursively. The citation closure of that paper might be easily 100,000 citations or more. So if you want to know what work has been done more recently that builds on that 2005 paper, you're at a loss. Nobody can scan 100,000 papers. So we've developed the notion of citation that gives you 10% of the citations to focus on and also ranks them by degree of influence. So you can home in on the key citations. We also exclude self-citations, right? People have been known to game the system by citing themselves a lot. And by the way, that also makes it fairer across genders because men tend to cite themselves on average more often than women by about 20 to 30%. So we just take out self-citations. We also exclude incidental citations. You know, I'll mention something in passing out of politeness or completeness, we'll throw those away. On the other hand, we will include implicit citations. Sometimes I'll refer to a particular system by name. I won't use the citation if it's famous, or I'll cite it once, but I won't cite it later in the paper. We'll capture those. And most importantly, we rank the citations by degree of influence. So degree of influence means that we build a model looking at two papers, and we decide to what extent does paper A influence paper B based on what's said in the papers. If you want more details on that, I have a short note on this in Nature, and I'll show this in the demo. In addition to this notion of semantic citations, we also look at things like the number of citations per year, citation velocity, or the derivative of that, citational acceleration, the change in the number of citations per year. And these metrics help us figure out what is current, right? Sometimes we'll have a paper from a while ago, and just over time, it'll tend to accumulate a very large number of citations. But if you want the latest and greatest, Semantic Scholar makes it a lot easier to find that. So it's worth taking a step back and just talking a little bit about how we engage with scientific papers, because I'm going to show you a whole bunch of features, but they all hang off of this conceptual structure. So first of all, we discover a paper, and that could happen via social means. Somebody sent me an email, or I saw it on Twitter. It can happen via search. Maybe I'm browsing a conference proceedings or looking something up in Wikipedia. I discover a paper that way. And in Semantic Scholar, we of course allow you to discover papers via search. We also have recommendations. We figure out which papers are related to which other papers automatically. And we also have the notion of a research feed that you can tune to your interests. So a lot of people have a Facebook feed or a Twitter feed or even a Spotify feed. Well, we have a research feed. And as you rate papers, I'm interested in this one, I'm more interested in that one, I'm not interested in this paper, it'll gradually tune itself to your liking. And you can come in every morning and see, okay, what's the latest information in my feed. Now, once you've gotten the paper, you need to make a decision. Okay, am I going to ignore this paper? Am I going to skim it quickly? Or am I actually going to read it, which is, again, happens a limited amount of time. To help you make that decision, we have quite a few things in Semantic Scholar. Obviously, we have paper abstracts, the traditional way of deciding whether to read a paper, but we do even more. We automatically highlight key sentences in the abstracts. We automatically extract figures and tables. You can, if you're more of a visual person, you can quickly look at a glance and get a sense of what the paper is about. We filter and analyze the citations. I talked about that. We automatically provide citation excerpts. One of my favorite ways to decide whether I should read a paper or not is look at what's been said about that paper. And then recently, we're just in the process of launching this. So it's in what's called an A/B test. If you go to Semantic Scholar, some people will see this, some people won't. It's called TLDRs, or extreme summarization. Let me say just a little bit more about that. Extreme summarization is basically taking a paper and its abstract and trying to summarize the whole thing in one sentence TLDRs. So here's a famous paper on deep learning method called self-attention or self-attentive embedding. And our TLDR for that is the simple sentence. We use a 2D matrix to represent the embedding, et cetera, et cetera. Actually, the window's obscuring this. I won't read this out loud, but we're able to map this to a single sentence. And the method we use is similar if you've heard of GPT-3. It's a generative language model, but tuned for scientific summarization. And I'll show you some examples of that. Okay, so talking only takes us so far. Let's see if I can share with you a demo. What I did is here, let me, I type Ken Goldberg. I figured I'd use him as my example just so I have a chance to catch up with some of his work, and also Ken can tell us if we're getting this right or not. So we have an autocomplete. I chose Ken, and these are the results. And I see I have an author homepage here. And by the way, I can see just how prolific Ken has been. We don't cover gray literature or I don't know, patents, what have you, and still Ken has close to 600 papers in our corpus. Ken, relax, kick your, learn surfing, something. So I click on Ken. And actually what's interesting here is before I delve into his publications, let's look at his influence diagram. So I mentioned we can figure out here who's influenced who. So here we see that Ken was influenced by his colleague Peter Abeel, and we can see which papers led us to conclude that. Also by Matt Mason, who I happen to know was his PhD advisor and from CMU days. And then on the other hand, we see that Ken himself, he influenced Peter Abeel as well. So there are papers by Peter that cite him, and other folks whom I don't know might be Ken's students or colleagues. Well, Algorithmica, I always wanted to publish in Algorithmica. So we have the ability to navigate this. If I'm interested in, again, delving into Peter Abeel, I can just click and again go to his influence diagram and so on and so on. So it's a pretty handy way to figure out expertise and such. Going back to Ken, let's look at his papers now. And so right, the default sorting is sorting by his most influential paper. So you see that it's had close to 1,500 citations. Only 103 of these were highly influential citations. So again, if you want to see, wow, what has been done since this influential paper in 2001, you have a much easier path to thing to focus on. I can also resort. I say, forget his most influential paper. What has he done for us lately? So I can sort by recency, where I'd have fewer citations, and he's been working on multimodal Gaussian shape descriptors. But I want to see what he's done that's really hot. So let's look at citations per year. And his work on grasping, we can see here is getting something like 150 citations per year, or I can even drive deep. What about the change in citations per year? And here I can see that his work on optimized path planning doesn't have as many citations, but it's accelerating quickly. So again, just different ways to dice and slice and go through Ken's corpus of work. And of course, I can also just search here. If I click on these, I've never clicked on this paper. Let's see what happens if I go to the PDP. So here you see that a particular sentence in the abstract was highlighted. You can see more of the context there. And also, I could go to the figures and tables. So I quickly get a glance of the results, what's going on here. And by the way, on a mobile device, and you don't need a special app, you can just go to a mobile device, it's very handy. This paper was cited 180 times. So again, I can go to the citations and I can sort through these. So here, let's say I want to sort through the papers that were most influenced by this. And I see here a paper from 2016. I'm going quickly so you just get a feel for this. And I can click and see 7 excerpts. So what are people saying about this paper? And we can see that in some cases there's citation. A bunch of places, again, they don't have the explicit citation. You just refer to the LQG, the aptly named, I should say, LQG-MP algorithm. And so we can see what's being talked about here. So I could go on and on for hours, but in the interest of time here, I'll stop. The point is there's a very rich feature set here with Semantic Scholar. And I'll skip ahead to the last part. And this is actually joint work with Marty Hurst and her student Andrew Head at Berkeley. And that is, we're not just working on discovering the papers, we're actually working on an interactive application that helps you read it and understand particularly the underlying mathematics at this point. So these days, how do you read a paper? Some people print it out, they're old school, that's me. Some people read the PDF online in CITRIS, but it's basically an inert process. And our idea in collaboration with Marty Hurst was that this could be a lot more interactive. So I can't resist and just quickly show this to you. So here's the interactive reading app for a particular paper. This is not yet widely available, but it will be by early next year. So here's the paper. It starts, and we might change this, but it starts with a glossary. So if you want to have definitions of the different terms, that's handy. If you want to see the references for the different terms, you can do that. And if you slide through here in the paper, we might look, okay, there's a reference to a paper. I could just click on it and wait, let me move this a little bit further down so it's easier to see. And it'll pop up an abstract on it. Soon we'll have the TLDR. I can save that paper to my library for future reference, et cetera, et cetera. And if I go further, and let's say I get into some of the equations, that's when it really starts to shine. So for example, when I click on this equation, say, I see a reminder of the definitions of the different terms, right, as per the glossary. And I can get a quick sense, oh yeah, so this is what this equation means. Right now we're paying a lot of attention to mathematical terms, but we're going to do that with other terms as well over time. So the point is, it just gives you more context that makes it easier for you to read the paper, to hop to the definition of a particular term, and so on and so on and so on. So again, I'm just whirlwind tour, but the point is we're going to change how scientists read their papers. To do all this, we have to change how NLP works. NLP, natural language processing, was traditionally focused on sentences and on short context. We are in the process of scaling NLP from the more traditional kind to document level NLP, where the context for a word or sentence can be the entire document. And when we answer a question, we might answer it based on the entire document, and so on and so on. I know this isn't an AI audience necessarily, so I won't go into the details here. I will mention as a computer scientist that there was a major innovation to do this kind of scaling because the attention matrix, when it's fully computed, is n squared in the length of the context, and we were able to turn it into an order n linear time algorithm, which allows us to have the context be much longer. So we're going from 500 tokens of context to 32,000. We're also looking at the special structure the documents have: citations, references, figures, tables, sections, etc., and using all those in analyzing the meaning of a document. So really what's happening for us, and this is rapidly becoming a grand challenge for all of AI, is scientific NLP. There's been so much work on tweets, on reviews. I've worked on that, as Ken mentioned, but science is kind of a poor stepchild here. And scientific text is where most scientists report most of their results. And we have a great opportunity to improve our automated processing of text using scientific NLP. And we're making progress there with leaps and bounds. So with that, let me shift to the story of COVID-19. What happened on March 6th of this year is a person with the august title of the CTO of the United States contacted us because he was aware that we had all this infrastructure for processing scientific documents. He contacted us informally through a colleague at Georgetown University, and he said he wants us to build a machine-readable corpus of all the relevant documents about COVID-19, SARS, MERS, the coronavirus, basically anything we could find in the scientific literature that will help people figure out key questions about this virus. And we said, of course, we'll do that. When do you need it by? And he said, yesterday. This is not some long-term scientific thing. You'll form a committee, they'll issue a standard. We need this right now. And I'm really proud of our team. They worked day and night, and within 5 days, we had the first version of COVID-19, the COVID Open Research Data set, and it was released 10 days later. And in those 5 days, a number of other partners joined us from the Chan Zuckerberg initiative. Preprint servers like bioRxiv and medRxiv made their tools available. NIH joined in the fray. Everybody did everything they could. And literally within 10 days, we had something available. It was announced in a press release by the Office of Science and Technology Policy at the White House. It got quite a bit of press attention. And today, this corpus contains more than 200,000 papers. It's updated daily. Thanks to a contribution of software from IBM, we're also able to analyze not just the text, but the contents of tables. Many medical papers contain tables with the key results. And Kaggle joined us to list key questions and to create Kaggle competitions for people to build tools to answer that. The data set was downloaded from us or from Kaggle over 2 million times, and it became the basis of the most popular Kaggle competition ever. And again, a whole host of institutes and institutions became involved. What I just want to end on is just show you some quick examples. I wish I had time to show demos. I'll just show you some screenshots, but of the publicly available tools that have been created, and there's really quite a few of them. Here's one out of Amazon AWS. It's a question answering system. You can ask questions like, how infectious is COVID-19? Or more technical questions like, are IL-6 inhibitors key to COVID-19? And here's a snapshot of what answers look like. This is from Korea University, a question answering system. The question is here, what temperature kills COVID-19? And we see that the top result is 56 degrees Celsius. You can also see, if you look closely, that it also makes mistakes, at least in this snapshot. So you need to be careful to read the sentence and delve to the particular paper. But again, it's an extremely powerful way to quickly get the information you need out of these scientific papers. We don't just look at a single paper, and single questions. We also look at claim verification. So something that was somewhat controversial a while back was, does mass masking reduce COVID-19 transmission rates? And we're able to delve into papers. This is joint work with the University of Washington and AI2. And we built a system that not only determines whether the statement is true or not, but shows where the support is for different claims, again, in this COVID-19 corpus. We also use scientific visualization techniques. So other researchers built something called SciCite that allows you to look at the relationship between proteins, genes, and cells. If you click on an edge in this circle, it'll show you the different connections. And if you click on that edge, you can go down immediately to the relevant papers. And there's lots more where this came from. So really, our goal has been with this work, and this is just a few months old, is to rapidly and critically connect the AI community and the medical community so we can benefit research on COVID-19. More and more medical articles are appearing that are using COVID-19 directly or using tools built on top of it to locate papers and to come up with the results. Of course, as you know, we haven't come up with a vaccine yet, but more and more medical analyses and meta-analyses of the literature are using COVID-19 and the relevant tools, which is very, very exciting for us. Taking a step back from COVID-19 and COVID-19, we really had a broad vision for Semantic Scholar that we reported on back in 2015 when the project started. We said, what if a cure for an intractable disease like cancer is hidden somewhere within the tedious reports on thousands and clinical studies and more? Could we build an AI-based discovery engine, not that it'll answer the question, but it'll help scientists, medical researchers to answer these questions? And of course, it's not limited to medicine. Science's thorniest problems, whether it's climate change or other topics, really requires scientists to be as effective as possible given the information overload. And these new tools like Semantic Scholar and others could really help there and ultimately revolutionize science. And of course, our frantic search for a vaccine shows how essential that is, not just for this pandemic, but for the next one. So with that, I want to go back as I draw to a conclusion to the question I raised at the beginning of the talk. Is AI poised to destroy humanity? Is it an existential threat, as we hear from Elon Musk and Stuart Russell and others? And I would like to highlight that I'm not a Pollyanna. I think AI raises very serious issues around privacy, around fairness, around job displacement. but I don't think it is poised to destroy humanity. On the contrary, I think the whole discussion of AI taking over the world that's kind of fostered by Hollywood is a distraction from the real problems that we have. The poet once said, you should have fewer imaginary problems and more real ones. We have real AI problems that we ought to be thinking about, not these imaginary ones. And then last but not least, there's the issue of benefit, right? We focus on AI for the common good. Think about self-driving cars. They're further out than we think, but when they come here, this is not some millionaire's plaything. It's going to save thousands of lives. We have 40,000 highway deaths on our highways each year. We have 1 million injuries in the United States alone, and self-driving cars could reduce that by 80 to 90%. So it's imperative that we get that out as soon as we can. And I'll end with this quote from my colleague, Eric Horowitz, who says it incredibly well. It's not that AI is poised to destroy humanity, it's the absence of AI technologies that is already killing people. When we fail to have self-driving cars, when we don't have drug discovery and vaccine discovery tools that are highly automated. And I'll stop with that. Thank you for your attention. Happy to answer any questions.
Excellent. That is great. Oren, what a great talk. We actually have a number of questions that are coming in on the side. I'm going to take the liberty of asking you a couple for myself, though, because I love this project. I have to say, Semantic Scholar, when it first came out, I was tracking it, and I hadn't seen a number of the new innovations. It's really interesting because obviously that's so much of what we live from. We our essential core product out of the university. And Google Scholar has made a lot of advances. This used to be a terrible old crufty system. You've now taken this in many number of new innovation directions, and it's fascinating. I really like. I mean, it was interesting to see what it pulled up for mine, and I want to go back and play with it, see how it's been updated. And in particular, there's a lot of nuanced decisions that go into it. As you said, the influential score is recursive, right? And there have been ways of talking about those metrics for impact factor for journals. And I know how much hinges on that because I've been editor-in-chief of a journal. It can be extremely stressful, and everybody worries about one little notch up or down. But these are more interesting metrics based on eigenvalues and centrality of the network actually are very, very helpful. The thing you always worry about is a little bit of the winner takes all, right? Where an article gets pushed up because of influence, and then it gets cited more and more, and it just keeps accelerating. So the first question is, how are you thinking about Semantic Scholar in terms of being able to find that sort of raw needle in the haystack that people may not have noticed, and not let that get essentially buried?
Yeah. So let me give two quick answers because it is a very rich topic. The first one is that we are making our data publicly available. So again, Google Scholar is a wonderful system, and has also made advances over the years, which is great, right? Rising tide is raising all the boats, but they generally have, because they're Google, have not been able to share their data. It's different from us. We have an API that allows you to get access to our data, and so to build your own application. So my first answer is, we don't legislate what you see. You can build a different one. There's an example, a super cool visual discovery system out of Israel called Connected Papers that has a very different way for you to find the papers that are of interest. The second thing is, we define more and more metrics that are attempting to fight this rich get richer phenomenon that you were talking about. So for example, we were playing with including tweets, which is there. We're looking at different aspects of metadata. So I would say that it is a real issue, and we're working on it as distinct from we have a silver bullet to solve it.
Good. Okay, great. Well, it's interesting you mentioned tweets because I have noticed, I've started using Twitter, and my students are, and it's becoming a really effective tool for sharing really fresh ideas. And so I'm glad to hear that you're incorporating that. And also I really appreciate that you're making the data open. In fact, that was Charles Yang's question. Will you be exposed to citation graph, exposing the citation graph when you are? And then, because it is such a rich area, and I think that having that full transparency. Another question I want to ask you about is archive. And one of the big questions is, Google Scholar uses archive, but archive isn't reviewed. And so you get this tendency that there's a huge flood of papers, might be done by high school students or such, and they get attributed so that people's getting a big inflation in H-index. How do you feel about that? Do you use it in Semantic Scholar?
So we use all preprint servers that we can access, and certainly archive fully. Overall, right, nothing is perfect. Overall, it's a very positive thing because you get access to the information quicker and better. Sure, there are situations where it's not vetted. Generally, people in our community are aware of that, and so they're careful with that. Something like the H-index, I don't hold a lot of stock by. That's why I think something like semantic citations or highly influential citations matter. So you can garner a lot of citations quickly, but you're not really influencing other people's work, right? They just mention you because maybe due to some accident or richer phenomenon, you become the source for some term. That won't show up in our semantic citation index because you only show up if paper really builds on your results in a very rich way. And so I think that basically what you're talking about is what's at the heart of this is that now that this information is online and increasingly digital, and now that it's more open, and it's more open because of us, it's also more open because of archive, right? I used to be the old science citations index that was, right? Because of that, we have the opportunity to experiment with this, both as AI people, but also as, library science and so on. So I think that this is something I'm actually very optimistic about, that we'll develop new and better metrics and ways to find genuinely influential papers.
Yeah, and I'll tell you another area that's hugely ripe, I think, for improvement right now, which is the flip side of that, which is the reviewing burden has grown immensely. So, there's so many new venues, conferences, journals, et cetera. So that there's more and more demand for reviewing. And what I found is, and I'm curious if you find this too, but a lot of times many scholars are delegating this to their grad students or colleagues. And then as a result, the review quality has gone down noticeably. And so, but that doesn't get usually factored in, and when the review is done, whether it's done by a first-year PhD student, and you get totally crushed by someone who doesn't really know the field. So I'm curious because if tools like Semantic Scholar could be used, for example, to allocate reviews to the right people and give them credit or something like that. Have you thought about that aspect?
So actually, more and more conferences in AI, including most recently IIII, have been using Semantic Scholar as part of their conflict detection and review allocation process. That doesn't address, unfortunately, the issue that you described, review quality in a time where, the number of papers has grown tremendously, and, basically, people are being drafted off the street and asked to review a highly technical paper. I've seen it in the streets of Seattle. It's or maybe that was QAnon theory. I'm not sure. But anyway, look, review quality is a perennial problem. I mean, there are cave drawings where people are complaining about the review of the cave drawings. It's that's not a problem we're going to solve.
Okay. Well, I just think it could be interesting if you could target something. For example, I'm much more likely to review a paper if it's really related to my work rather than if it's more distant. And we do have this problem, I tell you, for even science robotics. And their tools for helping me find the right reviewers are very primitive. So there's a real opportunity there.
Sorry, Ken, just to jump in, because you did hit on something I didn't really get to talk about. A lot of these things, like whether you recommend something, whether you'd be interested in something, whether you ought to review it, are a question of distance functions between points in vector space that represent documents. And we have actually done a lot of work on that. You know, a lot of the work on recommendations and distances has been done for, you know, songs or Spotify or products on Amazon, very little on scientific papers. How do you determine the distance between two scientific papers is something that we've really innovated on really in the last year or so. So we, for example, have, I think, probably the best interpaper metric for that sort of thing. So in that sense, you're absolutely right.
So that would be very helpful. And I can talk to you offline about that, Oren, because basically the idea is I get a paper submitted. I'd like to be able to run that through and pull up the 10 most relevant papers and then pull in turn those authors and see who is non-conflicted and who I might invite as a reviewer. All right, that's super, so cool. And I'm, you know, so many, we could just keep talking about this for a really long time. I love that there's a recommendation system essentially that I can sign up to that will now recommend new papers, because the biggest problem is also just the volume, but it's also the frequency. Because of archive, it's not only just when the conferences come out, it's constant. New papers come out, and I want to know right away if something comes out that's really relevant to me and my students. Okay. Great. And so just, we only have time for one more question, really. It's this one I really like. It's where'd it go? Oh yeah, here it is, by Alec Dara Abrams. So he is asking, what do you think about the difference between what he calls Engelbartian AI, which is the, you know, intelligence amplification, versus the McCarthyist AI, which is the, you know, get rid of the human, you know, fully automated system. And I call the first one complementarity, because I actually think it's fundamental that AI and humans are very complementary in their skill sets. And I think that's going to be with us for a very long time. So I'm just curious, because it sounds like you're very much on the side of the first.
Yeah, that's exactly right. So my favorite, and I was alluding to this obliquely with talking about tools and so on, is thinking of AI as augmented intelligence. So I very much believe that for the foreseeable future, computers will complement us. Of course, they already are, right? We've got reminder lists, yeah. We've got Google search engine use AI. We have so many ways AI is helping us. And I think the replacement thing is just, it's not that it's conceptually impossible, it's just that it's very far away from what we know how to do and from what's in the foreseeable future.
Right, and as you said with the canary, you know, the canary in the coal mine, that, you know, when we have to worry is when the AI system starts actually proposing the new problems and the creative new ideas, and we're nowhere near there. And that's where we need people, and especially people like you. And so, you know, it's that I really appreciate it. I think that is actually, you know, I think we're so secure to the degree that that AI can help us, free us up, so that we can spend more time having these kind of conversations and listening to innovative ways of thinking and new tools and new ideas. That's really where AI can support us, and we are certainly going to need some support in the years ahead. So thank you, Oren, for taking time out on this busy, specifically busy day. Thank you for this work that you're doing with COVID-19, really interesting and valuable. And thank you for always being stimulating and interesting mind and a great friend. Thank you, man.
Ken, thank you. Thank you all for the invitation, your attention. I really appreciate it. Take care.
All right.